Welcome to Brain Vision.
All right, today we'll be discussing the definition of a probability distribution. But before we get to that main topic, we need to review some of the simple terms we use in statistics. To start with, we're going to remind ourselves of the formula for probability, number of fatal outcomes divided by total number of outcomes. But we know there are other words we can use to simplify that formula down. To start with, we know we have a sample space. Sample space in an experiment or random trial is the set of all possible outcomes or results of that experiment. Now, when you're writing out your sample spaces, be sure to remember to include all possible outcomes. If you miss any of them, then your probability distribution will probably not quite work out the way you want it to. Next, we must remember that we have events. An event is an outcome or defined collection of outcomes of a random experiment. Another definition of it is any subset of a sample space. Pretty straightforward. It's the same thing as the favorable outcomes we discussed before. So then our formula for probability becomes the event divided by your sample space. Now, with those main terms defined and explained again, just a nice little refresher, we can go over what the definition of a probability distribution is. So, definition itself is a table or an equation that links each outcome of a statistical experiment with its probability of occurrence. Don't worry, we'll go over an example of this because that definition, while being straightforward, can be a little wordy and get a little confusing if you haven't seen one before. Now, we have to remember whenever we're making our probability distributions, one of the most important rules is that the sum of all the probabilities with all possible values included must equal 1. If it's greater than 1, if it's less than 1, then you're either missing a possible outcome or you're missing a possible event, or you're calculating for two events at once, or just something is wrong and you'll have to go over your sample space and the general data for the experiment. The other thing we must remember is the probability for a particular value or range of values must be between 0 or 1 and 1. We can't have any negative probabilities, and we can't have any probabilities over 1. If it's greater than 1, then it's no longer a probability. And if it's less than 0, then not really possible for what we're doing. So now for an example. For example, we're going to be going over a unbiased or unweighted coin toss, and we're going to be tossing our coin 2 times. So 2 tosses. Now, we're going to be looking for the number of tails obtained. We're going to define that as x. There you go. And before we start in our probability distribution, we need to write out our sample space. And a sample space, it'll be defined in these little brackets here. Well, not quite like those. They'll look a little more like that. There we go. Much better. So if we're doing 2 coin tosses, then we know we have a few options for outcomes, and we have to be sure we list all of them. So to start with, we have where the first toss is tails and the second toss is tails. After that, first toss would be tails, second toss could be heads. First toss could be heads, second toss could be tails. And last both tosses being heads. And that is our entire sample space. Those are the only 4 outcomes that we can expect to see from this experiment. Now, here, let me try to split it up a little bit. There we go. So now we're gonna start drawing out our probability distribution. Now we're going to be doing a table format today. Start with, you have your X and your probability equivalence. And this is the setup for just about every probability distribution table you'll do. It's the event you want to happen or event you are calculating for, or the outcomes you're looking for. So we're looking for how many tails will come up when tossing 2 coins, and the probability of that X outcome occurring. And for us, we know that we have 3 outcomes. And they are our X, where you have no tails occurring. We could have 1 tail occurring, and we could have 2 tails occurring. Those are all 3 of our options of how many tails could occur in 2 coin tosses. So with 0 tails occurring, the only instance of that is over here with our 2 heads. So with that, there's only 1 of them, and we have 4 options, so then our probability becomes 1/4. The chances of only 1 tail occurring are 2. We can see both of them right here. So we know we have 2 over 4, which can be simplified into 1 over 2. And then we have our odds of 2 tails being tossed right here. And that's another 1/4. Now let's double check our table. All of our probabilities are between 0 and 1. Excellent. Now the sum of our probabilities, or the total, well, that's 1/4 plus 1/4 gives you 1/2 plus another 1/2. We have 1. And based on the rules we discussed previously for a probability distribution, we know that not only do we have 1 here, we also know it's right, or much more likely to be right than if any of the other rules had been any of our 2 rules had been broken. And so with that is our definition of probability distribution, as well as an example of one.